I hope everybody's having a good snow day. Gonna try and shoot a little video here to get us caught up. Want you to remember QRS complexes, what everything is called. I'm not going to worry much about the, let me back that up. Not going to worry much about the shooting a little video to try to get us caught up on this snow day. Just as a quick reminder of what QRS complexes look like. This is their P waves. We're not going to actually use that in any of what we're doing today. The first positive deflection is R. The first negative deflection, I'm sorry, going to shoot a little video here in the snow day. Here's our P wave, just as a reminder. Of course, we're not going to really use that when we're looking at bundle branch blocks. The first positive deflection is an R wave. The first negative deflection after an R wave is an S wave. And then we have T, which again, we're not going to use. This one's a little bit different over here. The first negative deflection is Q, then the positive is R, then we come back down for S, negative deflection. This one looks even funnier. We have a positive deflection, so that's an R. Then we have a negative after the R, so that becomes an S. But then we come back up and have a positive. We call that R prime, and then it comes back down. This one here, we have an R, little bump, S, and it comes back up. When we're looking at our conduction system, remember our AB node, we have our internodal pathways that flow, and one of them comes down here to the AB node, then the bundle of His, and then this splits into different branches. We think about the right branch and the left branch. What we probably didn't tell you in EMT school is that the left branch actually branches into more branches, so it breaks into some other ones. There's the right bundle branch. We have the left anterior fascicle. We have the left posterior fascicle, and then we also have the septal. Although we don't really look at the septal block very often when we're talking about bundle branch blocks. Now we can have 1, 2, 3 of these blocks, so we can have a monofascicular, a bifascicular, trifascicular. If all 4 of the branches are blocked, it's a complete heart block, and then your patient has some other issues going on. You probably have a 3rd-degree heart block. Now, if we did have a block, let's say we did a complete block on the left side, it's not all over for the person. It comes down here to the right, and it will cause the right to fire. And then eventually it will start to come back over here to the left. So the left will fire after the right. And that leads to a little bit of a delay, which is why we have this funny kind of notched wide QRS complex morphology. When we're looking for bundle branch blocks, all we really want to look at is lead V1. And here we just check out morphology. So if I have a right bundle branch block, I'm going to have an R, S, R prime come back down to the baseline. On a left, and we call this terminal R wave, or R prime. On the left, we have an R, S, and it comes back up. So we have what they call a terminal S. We can also use a turn signal indicator to help figure out which is which. If I go backwards a little bit, if I have an upwards deflection, just like if I had flipped my turn signal up on my car, it means I'm probably turning right. And then if I push down on my turn signal, so I go down, then I would be going left. So do I have a bundle branch block at all? Here's what we look at. Do I have a wide QRS complex? And if I do, then I look for the RSR prime pattern, or I look for terminal S pattern. And that tells me if I have a right or left. So we may block part of one of the fascicles. So we could block, let's say, just the left anterior, or we could do the posterior. And again, just like with a right versus left, there's going to be some energy that will eventually flow around to the part that doesn't initially get it. And we don't usually look at the septal, but just realize that you can have a septal hemiblock. So if the left anterior one was blocked, just remember that the electricity will flow down the posterior one and eventually come back this direction to get the rest of the left side of the heart. So it's not like it's end for the patient. Here's how you tell. I'll let you take a moment to read through all that. because that's really too much for me to remember, but I'm sure you've got it. I don't. So looking around, I tried to come up with something or find something that would be easier to remember. And what became easier to remember for me was this Q1 S3 thing. So do I have axis deviation in this one? I have a really good 1, and I have negative AVF. And remember, if we draw our quadrant, so I'm moving towards 1, and I'm moving away from the foot. So that would put the signal in that direction. And so that is a left axis deviation. So I see that. Then I need to look to see if I have a small q in lead 1, and I think I do, and then a large S in lead 3. And I definitely have that. So if I look at it a little bit closer using that Q1 S3, you can see that. Now the left posterior hemiblock, again, there is this, and if you really can memorize all that, that's awesome. Because this, if you have all this, there's no doubt then that you have it. But I can't remember all that, so I remember S1 Q3, and that makes it easier for me. Now with the left side being blocked, the left posterior hemiblock, the energy is sort of moving in this direction, so it looks like it's coming from the right. So I need to see if I have a right axis deviation, and then S1Q3. So if we blow this one up, right axis deviation, yep, I'm negative in 1, I'm positive in the foot. So again, my quadrant, if you use that method, I'm negative in 1, positive in foot, so that takes me this direction. Sorry, trying to draw with my fingers, don't make the best arrows with those. Do I have a small S in lead 1? And I do. And do I have a Q wave in lead 3? And I have a little one right there. But that's all that I need for this. And then we can have bifascicular block. Now to have a bifascicular or a hemiblock, I have to have the right bundle branch blocked, and then I have a left side block. And it could be a posterior or an anterior fascicle that's blocked. So looking at the EKG here, I definitely have a wide QRS complex, so I have a bundle branch block of some sort. I have a terminal R wave, so that makes it a right bundle branch block. And then I look at my axis deviation, and I think I'm going towards the towards the 1, and I think I'm going away from the right. So that makes me think that I have a little bit of left axis deviation. And I look for Q1 and S3, and again I have a little Q1 and I have a big S3, little q, little q, big S3. So I have a left anterior fascicular block or left hemiblock. So this is the bifascicular block. And here's a few other ones for you to take a look at. Now remember, this might be left, it might be right, or it might be a bifascicular block. And go ahead and pause the video if you want to try to figure this one out. The way I see it is I have a wide QRS complex. I have a terminal S wave, so this makes it a left bundle branch block. Another one. You begin to identify that morphology, but I have a wide QRS complex. I have a terminal R prime wave coming down into my T, so that makes it a right bundle branch block. So if I have the right bundle branch block, I then have to go back and look to see if I have a blockage on the left. If I look at lead 1 and AVF, I'm going to say they're both kind of going towards the direction like they're supposed to, so that's a normal. So I don't have axis deviation, so that makes that just a right axis, a right bundle branch block. V1 again, looking at that, I have a wide looking QRS complex and I have a terminal S wave, so I probably have a left bundle branch block. Look at my axis deviation, positive in 1, negative probably in the foot. So I'm going a little bit more towards the left. I could make a case for a left anterior hemiblock, I think, with this one, except I don't really see the Q in 1. I do see the S in 3, and I don't see a Q in 3 at all. So, just a left bundle branch, not a hemi. Gotcha on that one, maybe? Just looking at a normal EKG. This one's probably not normal. I see a widened QRS. I see a terminal R wave. So that gives me a right bundle branch block. So then I look for axis deviation, and I see +1, ABF. So all I have is a right bundle branch block. Normal ECG. All right, this doesn't look normal. Again, a wide QRS complex. I have a terminal R prime wave, so that makes me think I have a right bundle branch block. Do I have axis deviation? Probably +1, definitely -F. So looking at my quadrant, going towards 1, away from foot, puts me into left axis deviation. And then do I have a Q1? I do. Do I have an S3? I do. So that's a right bundle branch with a left anterior fascicle block. So wide QRS complex, terminal R wave, so it makes me right bundle branch block. Definitely -1, positive towards the foot. So draw my quadrant, -1, positive towards the foot, takes me down there into the right axis deviation side. I have a big S1 and a little Q3, so that's left posterior fascicle. Wide QRS, terminal R wave, right bundle branch block. Do I have axis deviation? I am negative towards the foot. I am, I'm going to say a little negative on the right. That's kind of a bad EKG to be reading, so that makes me, I'm negative or positive, it'd be hard to say. So I look at my Q1, S3, and depending on which one of these you look at, you might be able to make a case for a real tiny Q wave because the QRS complex is so little, but I definitely have a big S3. So that would make me think the posterior block. Hope this helped. If you have any questions, shoot me a message. Otherwise, I'll see you in class later, and we'll try to discuss some more.